Today we're going to be exploring a connection between mathematics, art, and architecture. Evidently, there is a pretty significant relationship between math, art, and architecture. In art, ratios in regards to canvas size and the size of the subject of the painting is very important to ensure things don't look wonky or disproportioned. In architecture, measurements are absolutely essential to ensuring the structure is strong and everything fits. If one measurement is off by the tiniest of fractions, it can have a domino effect on many other aspects of the build. The mathematical element in art and architecture goes deeper than just simple measurements. We have to go way back. No, not that far back. All the way back to around 500 years before Christ. A Greek sculptor and mathematician named Phidias studied what is known as phi during the construction of the sculptures for the Parthenon. Phi is also known as the golden ratio, which can be explained through the use of the Fibonacci sequence discovered by Leonardo Fibonacci in the year 1202. But what do these fancy math terms even mean? To understand them and their use in art and architecture, I'll start by explaining the Fibonacci sequence. Although it was discovered later, it perfectly explains the golden ratio, aka phi. The Fibonacci sequence is a sequence created when it starts with a 0, then each preceding number is from the sum of the two preceding numbers. So here we're starting with 0 plus 1. Then you take the 1 and the sum, which is 1 as well, and take those and put them through the next equation, which is 1 plus 1, which equals 2, and then you take the 1 and the 2 from those and continue moving forward where 1 plus 2 equals 3, and this will continue infinitely. Now if you take each sum and divide it by its preceding number, it's when you start to notice a pattern. For example, 2 divided by 1 is 0.5, 3 divided by 2 is 1.5, and this will continue on infinitely as well, just like the Fibonacci sequence. You might have noticed, as the numbers get larger, they all approximate the same answer, 1.618. This remains true no matter how large the number gets because the ratio stays the same. This is known as the golden ratio. This ratio can be seen when creating a rectangle where the side x is equal to 1, and when adding x and y together, you get 1.618. This is known as the golden rectangle. Looking at the green rectangle, it is also a golden rectangle itself as it has the same 1 to 1.618 ratio. The golden rectangle can be infinitely divided to create more golden rectangles. It will look like this. Now if a spiral is added through each of these rectangles, the result will be the golden spiral. As the spiral continues through the rectangles, it gets wider every quarter of a turn by a factor of 1.618. This proportion is known as the divine proportion. After it was discovered, it was noticed throughout nature, plants, the galaxy, shells, human proportions, etc. Not only does it surround us, but humans find it very aesthetically pleasing, well-balanced, and strong. It has been used in ancient architecture, art, and is still used in modern times. Here are some examples in ancient architecture to show how the golden ratio is used. The Notre Dame Cathedral in Paris originally started construction in the year 1163, and it is almost 400 feet long and about 140 feet wide. In this photo, we can see how the golden rectangle represents itself a multitude of times in the various distances between certain pillars and towers. The Taj Mahal is an ivory-white marble mausoleum on the south bank of the Yamuna River in the Indian city of Agra, and it was originally commissioned in 1632. For some reason, iMovie wouldn't let me put the whole photo in, but we still get a clear idea that there's a golden spiral between the two front towers, and which most likely means that there's also a golden spiral with the back too as well. And we can clearly see that between the top dome, there's a perfect rectangle in those distances, as well as in the base between the two towers, which also lines up with the main entrance. Here we have the Parthenon, which is located in Athens, Greece, and initially started construction in the year 447 BC. As Phidias participated in the construction, it's very obvious that there would be a golden rectangle completely, perfectly encasing the front of the Parthenon. Here we have the very famous Eiffel Tower in Paris, France, which originally started construction in 1887. Here we can see the dimensions between the bottom, the middle, and the top of the tower perfectly fit a golden rectangle. Those are just a few examples of mathematics being implemented in architecture. Now we're going to be going through some examples of mathematics in various paintings. This is The School of Athens by Raphael. Here we can see various golden rectangles between the archway and people, dividing them perfectly. This is The Birth of Venus by Sandro Botticelli. In this painting, we can see how each of the subjects perfectly fits their own golden spiral. This is The Great Wave of Kanagawa, created by Hokusai. In this painting, the curve of the wave perfectly follows a golden spiral with its proportion. This painting is called Salvator Mundi, and it was painted by Leonardo da Vinci. In this painting, we can see how the dimensions of his face perfectly fit the golden rectangle. This very well-known piece is called The Creation of Adam by Michelangelo. In this painting, it's very clear that the golden spiral perfectly follows the outline of Adam. The very same demonstrations of these mathematic principles can be found in many other paintings throughout history. The examples I have shown today are simply the tip of the iceberg for the various applications of these mathematic principles throughout different art pieces and architecture throughout the entire of human history. To end things off on a more modern note, here we can see how these mathematical theories can be applied to technology of today.